The two types of fermentation are alcoholic fermentation and lactic acid fermentation. For alcoholic fermentation, it begins with glycolysis. Glucose, a sugar, is converted to two pyruvate molecules. Two ATP are formed and two NAD+ in the process are reduced to two NADH. To make sure glycolysis can continue, NAH+ should be regenerated. In alcoholic fermentation, two pyruvates further undergoes decarboxylation to 2-acetaldehyde, which is a derivative of pyruvates. CO2 is released during this reaction. This derivative can be the electron acceptor of NADH. So NADH gives its electrons to acetaldehyde and oxidizes to NAD+. Glycolysis cannot continue. Through the regeneration of NAD+, 2-acetaldehyde is reduced by NADH to produce 2-ethanol. This is a kind of alcohol that humans consume. Hence, the term alcoholic fermentation. Yeast can also do the alcoholic fermentation in making bread. The CO2 we mentioned can help bread rise because the fermentation time is very short. Only a small amount of alcohol will be produced. They will evaporate during the baking process. Next, let's move on to lactic acid fermentation. Again, glucose produces two pyruvate, two ATP, and two NADH. Unlike alcoholic fermentation, this time, the electron acceptor is pyruvate itself. NAD+ is formed and can be used by glucose. Pyruvates will be directly reduced by NADH to produce lactate. No CO2 will be released in this step. Lactate is a conjugate base of lactic acid. The production of this compound by certain fungi and bacteria can be used in the industrial production of cheese and yogurt.
For the first example that we want to talk about is the biorefinery of brewer's spent yeast and brewer's spent grain. Brewer's spent yeast and brewer's spent grain are prevalent byproducts of the brewing industry. Actually, by now, the majority of these byproducts are only discarded and not have many suitable treatment processes or repurposing of them. And here, the technology that I want to introduce is adding brewing and malting byproduct into lactic acid fermentation. For the first step, hydrolysis of brewer's spent grain and malt fructose mixed with distilled water to produce BSG-MR hydrolysate, which was used as the lactic acid fermentation medium. And then, the next step, also the main reaction, brewer's yeast extract and soy lecithin were added to the BSG-MR hydrolysate to perform the lactic acid fermentation. The results of this research suggested that the combination of industrial byproduct BSG-MR hydrolysate, soy lecithin, and brewer's yeast extract could make a very suitable fermentation media for cost-efficient batch and fat batch LA fermentation. And now let's turn to the next example of grape seeds.
Grape seeds, a byproduct of the wine industry, can be used in biorefineries to obtain energy and reduce energy costs. It can be achieved by, firstly, converting grape residue to syngas through a biomass gasifier, and secondly, delivering the syngas to an internal combustion engine to drive a generator and an anaerobic digester generating biogas that is delivered to an internal combustion engine to drive a generator. We are going to talk about the next example of apple pomace.
An apple was walking on the street. He saw a wine factory and walked into it. In the factory, he stayed with his apple friends and became apple wine and apple pomace during fermentation. Apple pomace was sad because he thought that he was useless. So we collected this apple pomace and sent it into a biorefinery system. In the system, he was happy to find that there were also many useful components in his body. He had dietary fibers including cellulose, hemicellulose, lichen, gums, and so on. There were also easily fermentable sugars, vitamins, proteins, and others inside his body. Most of the components can be converted into bioenergy, biochemical materials, and other products. Through thermal processing, three technologies were used to generate hydrogen, hydrotreat, fatty acid, biochemical, and so on. In the fermentation process, ethanol, quercetin, glycosides, and so on were generated. There were also other technologies in the system. The anaerobic digestion generated methane, hydrogen, and digestate. The composting process generated composts, and the extraction, biosorption, and other technologies generated phenolic compounds, retentate, and so on. The applications are mainly about using methane, hydrogen, and adverse materials as bioenergy, and using composts. There are also other usage of the products. For example, fatty acid is used in food, soap, and detergent productions. Digestate is mainly used as soil conditioner. At the end, Apple Permins was satisfied with the biorefinery system, and the story had a happy ending.